This is what the production process looks like for the latest Ford Explorer EV. It's an electric crossover SUV that shares the same name as the larger United States Ford Explorer. However, it's made in Germany and is available for the European market only. Giant pressing machines at this Ford plant create body shapes from aluminum and steel sheet metal. Now the car body manufacturing process begins. As you can see for yourself, much of the work is done by automated robots. First, the floor, sides, and ceiling are assembled, and as many as 4,000 places are welded. Robots are not only cheaper to run, but above all, they perform their work 24/7 with greater precision. That's why they are replacing more and more employees in car factories every year. Now, the welded body of the car will be sent to the test scanning labs. Here, they work primarily with the computer. Using special cameras, the entire bodywork is scanned into the computer, and all folds and joints are checked. Approximately 1 car in 1,000 is sent to this laboratory. There must be no defects in the body of the car. The thickness of individual body parts is also measured here. They must not be too thin or too thick. It is worked to 1/100th of a millimeter. These tests are, of course, carried out by other car companies besides this Ford factory in Germany. This is one of the most advanced parts of the production process. Ford's historic plant in Cologne was transformed as part of a $2 billion investment into a state-of-the-art electric vehicle. A second EV, a new sports crossover, will be revealed shortly with production in Cologne, starting later this year. The new all-electric Explorer combines German engineering, American attitude, and superior standard specification that includes battery electric powertrains for zero tailpipe emissions while driving. Now the inspected car body is moved by sliding tracks to another station inside this Ford factory. The entire movement of the car body is automated without the need for human intervention. Employees just check everything on the computer. The next station is the anti-corrosive coating. The body of the car will be completely immersed in the protective liquid. Please let me know in the comments how you like the production process so far. This is the only way to ensure that the protective paint reaches all creases, joints, and corners of the car body. The body is sprayed with a special paint and then dried. This part of the production process takes the longest time due to drying. The body shop will again move to another production hall, again using sliding belts and special feeders. Here, Ford factory workers inspect everything and coat the joints with a protective coating. This is followed by brushing the entire bodywork. These robotic brushes polish the bodywork of all irregularities and possible deposits. The Cologne EV Centre also includes digital technologies that connect machines, vehicles, and workers. To ensure high quality and efficiency, The factory will use self-learning machines, autonomous transport systems, and real-time big data management. Together, these factory systems can learn and adapt to become more efficient over time. This process in the production line is relatively new and not yet so well established among automotive manufacturers. The result, however, is a perfect base for the color spray. The appearance of the car then looks fantastic. Now the final paint will be applied to the bodywork. Everything is automated with robotic arms. This achieves an even coat of paint on the body of the new Ford Explorer EV. At the same time as the bodywork is being painted, the battery and the entire chassis of the car are being assembled. The front and rear axles of the car are then attached to the battery pack in the floor of the car. The installation of the wiring and interconnections is the responsibility of the car factory employees. Completely prepared chassis and connected cables will now move to the main hall, where the prepared body is waiting. Now the car body is lifted by crane and then lowered onto the prepared chassis. This part of the car manufacturing process is called the marriage. Car manufacturers around the world speak about a marriage when they insert the chassis, transmission, and engine in the body on the production line. This is where the chassis and bodywork of various Ford models come together. This line automatically assembles chassis with bodywork in minutes. This process runs continuously. While one part of the workforce prepares the body of the car, another part of the factory assembles the chassis. Now the final assembly of the car begins. Here, everything is manufactured mostly by workers in the factory. The robots can't, for example, connect the wiring and fit the small parts. The front dashboard is installed first, followed by the wiring between the engine and the rest of the car. An employee can wire the steering wheel, rear-view mirror, and other interior components of a new Ford in minutes. The doors are fitted last. The reason for this is to make it easy for employees to get inside the car. Now the final quality control begins in the illuminated LED tunnels. Thanks to the white light, trained employees can easily detect uneven bodywork, scratches, and other problems on the car. After this quality control, it's just a matter of testing all the elements and the test track. The new electric Ford Explorer features an angular and very original front bumper. How do you like it? This electric version of the Ford Explorer shares its name and design inspiration with the larger Ford Explorer SUV produced in the United States. The differences between the German Ford factory and this factory in the United States that you're looking at right now are pretty big. The Ford Explorer SUV is still assembled at this American Ford assembly plant in Chicago today. Almost all welding and pressing work is done by robots instead of Ford employees. It currently employs over 4,700 people. The factory was opened in 1924, and it has been producing Ford vehicles almost continuously ever since. The Ford Explorer has been built here since 2011. In that time, millions of these popular SUVs have been assembled here. So now you're watching the 6th generation Ford Explorer being welded right now, all of which are destined for the United States market. A visual inspection is also carried out after the welding process. After the robots, everything needs to be checked properly. Also, robots make mistakes. This is done manually and by the eyes of a trained worker. These self-driving robots do the work instead of Ford factory employees. Robots work without pay and are more reliable. This popular SUV is built on the Ford CD6 platform. A related car is the Lincoln Aviator. All processes in the production chain are controlled and monitored at this control station. Here, you can see the complete assembly of the gearbox, and then the whole engine. As you can see, the chassis body connection here is very similar to the European Ford factory. Its performance, reliability, and durability make the Ford Explorer a premium vehicle and one of the most popular SUVs worldwide. Front and rear wheels are mounted by employees using robotic holders that make their job easier. In its 100-year history, the Chicago assembly plant has proven that it can adapt to all kinds of changes. Quality control takes a few dozen minutes. If defects are found on the car, they are immediately repaired, and it is determined how they could have occurred. Any scratches or irregularities on the body paint can also be easily repaired here by sanding. Now the finished 6th generation Ford Explorers will take to the test track, which is right next to the production plant. There, drivers will test all driving characteristics. All lights, wipers, horn, radio, and other Ford controls are tested. Once tested and logged, the finished cars can be loaded onto trains and sent out to their end customers, maybe even to you.
This is what the quality control looks like at the Dingolfing factory in Germany. Together, we'll take a look at robots that assemble the car body and then the work of BMW employees. This is how car turn signals are tested. And now the electronics will be tested from the driver's seat. Everything must be flawless. But let's start at the beginning. The first step is car stamping. This gigantic machine is called the Giga Press and weighs around 40 tons. Now the car body is being moved to the welding hall. Welding is used to join together different metal parts of a car. It is an excellent method for joining two metals permanently. Since the whole body and structural components of the car are metallic, welding is a viable solution for joining those components. This BMW has about 4,000 spots welds at multiple locations. These orange robots are from KUKA. This company, along with Fanuc Robots, are almost the only suppliers of robots to the automotive industry. In addition to BMW, they can also be found in Volkswagen, Skoda, Tesla, and Mercedes-Benz factories. Last year, around 270,000 BMW cars rolled off this assembly line. The biggest challenge is to weld the aluminum, which is only 1.5 millimeters thin, as even the smallest mistake would cause the tank to leak. That's the Champions League of welding. Next part of the production of the new BMW M5 is paint shop. This is the top coating process. Each car is painted one by one with its designated color, and finally a clear coat is sprayed to add luster. Dingolfing factory produce up to 1,600 BMW automobiles a day, as well as body shells for all Rolls-Royce models. In addition, chassis and drive components as well as pressed parts are manufactured on site. In total, the location has a workforce of approximately 18,500 people, plus 850 apprentices. They handle the end-to-end production of flagship BMW models like the 7 Series, 8 Series, and M5 Sport sedan you're looking at right now. BMW manufacturer has fully automated lines that take between 14 to 18 hours to finish painting a single body. The result is layers of carefully laid out coats, all of which put together is only slightly thicker than the average human hair. After the car body dries, inspectors rigorously check the painted surface. The panoramic sunroof is single piece and just one robot can assemble it. This part of the production process is the beginning of the main assembly line, where workers are still used the most. On the assembly line, the car skeleton is slowly moved along moving belt. Each worker has a fixed time in which to complete their part of the assembly. In this way, the number of cars produced in the car factory is always the same. This is how the fuel tank is attached from underneath the car. The connection of the chassis to the car body is almost automatic, only under the supervision of a worker. This is drive shaft with front and rear differential, brakes, and engine. It now engages the elements almost in the middle of the car. The wiring and electronics will be connected. It's basically a Lego puzzle. Next is the installation of the front car dashboard. This is made in one piece from suppliers in another part of the Dingolfing factory, and is easy to put into the new car, as you can see. One worker can do it. This is massive 14.9-inch control display, housed in a single piece of curved glass. Nothing for lovers of classic indicators. Now, of course, all the seats will be installed. The next part is to prepare the chassis for connection to the rest of the body. This part of the production of each car is called the marriage. Car manufacturers around the world speak about a marriage when they insert the chassis, transmission, and engine in the body on the production line. It happens right after the drivetrain sub-assembly is completed. The latest BMW will be ready soon. Workers are preparing the mounting for the wheels. This is how the front bumper is attached. This lady is going to attach the steering wheel. The average salary for these BMW workers is around 20 euros per hour. But this is only a very rough estimate. Now you can finally see how easy it is to add wheels at the factory. The workers have an extremely large wheel lifter to lift the wheel, and all the bolts are added at the same time. Complete assembly of all wheels takes less than 1 minute as workers are on both sides of the car. Workers in the factory are often helped by robotic arms, so that they don't have to carry anything heavy themselves. At the end of the entire assembly line, there is a final quality check. The test driver takes the car to the drivability test facility. Here, basic engine performance data and some of the car's electronics are measured. Quality control can also spot problems before the product is marketed to consumers, leading to better quality. It can ensure that these products meet BMW standards. For some components, like the emission systems, meeting the right standards is essential. Inspectors are now confirming that the correct parts are fitted to the vehicle. And then they look for any scratches or dents. Next, inspectors check and adjust the lights, gauges, and any unusual noises. Then confirm the effectiveness of the accelerator and brake pedals. Only vehicles that have passed all these rigorous checks are delivered to customers. All of this is done every day on every vehicle delivered in Germany and around the world. Automotive manufacturing quality control ensures that vehicles are free of defects and operational issues. At this station, there are 2 to 4 workers per car, and each of them checks something different. This 5 series of BMW cars is, in my opinion, the most beautiful ever made. As a bonus, I have here for you a short demonstration of the production process of battery cells and their packaging for transport between individual parts of the BMW Group factory complex. Covering an area of around 6,000 square meters in the west wing of the Dingolfing component plant, equipment for manufacturing battery modules will be set up, along with a battery assembly line. The first systems are currently being installed and will be tested sequentially.